Hello, this is the third part and maybe the last part of this presentation. It will be to skip some slides, but I will just concentrate on the most important ones. Okay, now after reviewing the contention-free multiple access, where we need backbone structure like organizer for the network in order to divide the radio resources between all terminals. Now what happens if we have ad hoc network? In ad hoc network we don't have such organizer. So let us think about the same example of the classroom with the students. How could we achieve successful communication between pairs of students inside the classroom without the organizer, or without the teacher who control the communication? Okay, one possible way that everyone has a message that he or she wants to send it to the destination, to the other student. Just when the information comes, then they just say it. Okay, and now we assume that the destination, they know the message is for him or for her, and for the others they don't care, so the message will be delivered. Okay, now just they say wherever that this message come. When there's two pairs talking already, and when you have the message and you send it, it might not be delivered because of the interference or because of the noise. Because of that, we need to have acknowledgement. So the terminals, every terminal, wherever they have a message that they need to send, they just send it. Okay, they just send it. So how they know that it has been received or not? Based on the acknowledgement. So the receiver, once it received the message, of course the message has address, so the receiver knows that this message is for it, and then they will reply with the acknowledgement, positive acknowledgement. That means that it was received. If the transmitter didn't hear any acknowledgement, then they might send the same message again. So this is called Aloha protocol. Of course, it is not efficient, especially in case that when we have many terminals, okay, and they need to send frequently. So what we have here, we have the carrier sense multiple access with collision avoidance. So in this protocol, if we apply it in the classroom example, that it is like polite communication. So assume that one student, he or she wants to talk, and then before he or she start to talk, they listen. So okay, now there is no one talking, then they say their message. Okay, and then they wait for the acknowledgement. If there is someone talking, then they will not say anything, just be silent until that, and give some time before they re-listen again to the channel. So this protocol is called carrier sense multiple access with collision avoidance, that they try to avoid the collision by some protocol, as we can see here, for example. So the idea, assume that transmitter A wants to send to transmitter B, transmitter A wants to send to the receiver A, and transmitter B wants to send to the receiver B. Okay, now if transmitter A, they have a message that they want to send, they will listen to the channel, and if there is no one sending, then they will send a packet is called ready to send. That it means that I have something to send. Of course, in this package, or in this packet, there is also the address of it is receiver. Okay, and then if the receiver listen to this RTS, they will also listen to the channel. If there is anyone transmitting now, if there is no one transmit, then they will send what is a packet, which means that it is clear to send. So now you can send because it is available, the channel is available. Once the clear to send packet received by the transmitter, they start to send the data. Then the data is decoded at the receiver. Once it is decoded successfully, then it will send the acknowledgement to the transmitter, then the transmission has been done. Okay, during this time, it is the channel becomes unavailable for the others. So for the B, for example, if they want to send and they listen, there is a transmission already between A, transmitter A and receiver A, then they will not send anything. They just wait and go to the waiting list until it becomes, the channel becomes available again. This protocol is one of the contention-based multiple access, because all terminals, they are competing for the same resources. There is no division between the resources in a regular way because of the missing of the organizer. Okay, so this type of or similar type of protocols, they are widely used when we don't have like base station like in serial network. So example, like for example, we have in some kind of contention based in Zigbee network, or also in 802.11 protocol and so on. This is the called Wi-Fi. Okay, so in telecommunication, it can be divided into two parts, like wireless or wireline. We will talk about wireless later, the next slide, but about wireline, we might have the fiber optic, and we have coaxial, and we have a twin like pairs and so on. So the wireline is we have limited choices actually. In wireless communication, we have much more choices. As you can see, that wireless communication not necessarily to be only electromagnetic, it can be also ultrasonic based, which is used mainly underwater, and we have electromagnetic based, which can be like also in the in non-visible light, like in infrared, or it can be also invisible light like VLC. And we have radio waves. In the radio waves, we can divide them into short range, medium range, and long range. Long range mainly is for the wide area network. Medium range is called local area network, and for the short range, we call them like personal or private area network or personal area network. A few examples of the short range is Bluetooth, Zigbee, RFID, like near field communication, ultra wideband, and so on. So those are a few examples of the short range communication. They are widely used in smart grids, for example, and to communicate between the smart grid and the equipments inside, for example, the apartment, for example, and also between the smart grid, and sometimes you need to take reading of the smart grid. Even it would be possible to transmit this signal wirelessly, but if you want to have some information on your mobile phone, then you just close your mobile to the smart grid, to the smart meter, sorry, and then you can read the data over RFID, for example. And a medium range like Wi-Fi and also millimeter waves is a few examples about medium range or local area network, where we can connect different equipments together. And for the long range, we have two paths, like standalone or third party. Okay. What are the difference? Actually, in many like energy or utility operators, or for in power systems, for security reasons, many of them, they don't prefer to use third party, even it is much more like much cheaper and inexpensive actually solution for the fast deployment of communication systems inside the power system. And in the third party, you can just simply use the mobile network like 5G, LTE, and so on, or you can use also satellite networks. But of course, those the infrastructure of these networks are owned by mobile operators. It means that they are third party, so they are not under the control of the power utility or the power system operators. And in that case, they might have also standalone communication like Tetra or microwave links or WiMAX. You can of course buy a WiMAX, private WiMAX network, and like a CubeSat network. Of course, nowadays they are it is a new facility that one can use, like CubeSat. Of course, using a complete satellite system is really expensive, but the CubeSat is much more cheaper, and they can also handle many of the required operations. So those are a few examples on how to divide the communication over the smart grid communication of like distribution or communication protocols available for wireless connectivity. And the concept actually of standalone and third party, it was under discussions for a long time. So in power systems or power utility, usually they use some, like for highly secure communication, they might use standalone communication system, but for the general, like collecting data from smart grids or from smart meters, for example, they can use the third party. Okay. So you can see here, for example, communication system or communication between smart meters and consumer, like appliance, can like lamps or air conditioners, heating systems, for example, can be performed with short-range wireless communication like Bluetooth, or even with home Wi-Fi if available. Smart meters could be integrated with wide area network like cellular network or for direct communication. And as I said in the beginning, so we can also use concentrator to collect data first from many smart meters before they transmit them together. Okay. And also there is communication required between power system devices, for example, for the purpose of sensing, control, and protection. Okay. Now if we compare between wireline and wireless, the red color means that they are the negatives, and the black one is the advantages. So for the wireline, the advantages are higher security, yeah, because you can achieve higher security by direct connection of wire between. And on the other side, you can see that in the wireless communication, it has lower installation costs, free mobility, easier for reconfiguration, but of course it has disadvantages like highly dynamic and uncertainty of the channel, which means that we will need more complex like transmitter and receiver in order to equalize the channel, for example, and to estimate the transmitted signal and so on. Okay, and there are some facts actually also about the prediction about the usage of wireless communication. So the number of connected devices to Internet Protocol network, IP network, will be more than 3.5 times larger than the number of a global population in 2023. It means that within 3 years, the number of devices connected to the IP network will be around maybe close to 20 billion devices. Okay, and machine-to-machine communication or connections will be half of the global connected devices and connections by 2023. So half of the connections will be like machine to machine, and this reflects the importance of the wireless communication in smart grid, for example, and in smart city and in factory applications. So there will be a lot of devices connected to each other, talk to each other, device to device or machine to machine, directly through the IP network. And sometimes it's just called also Internet of Things or machine-to-machine communication. 5G devices or network will be like the platform for about 10% of the global mobile devices by 2023. More than 70% of the total IP traffic in 2023 and beyond will be handled in the last mile by wireless transceiver. So wireless communication will be major part in the communication infrastructure in also in the machine to machine or in the industry sector. Okay, So wireless IP traffic includes many different applications such as in smart grid, smart city, wireless automation, e-government, military, smart homes, remote monitoring and control, e-health and safety applications. In this simple figure, we can see the development of cellular network. So you can see that in from 81 to 90, the system was first generation and it was based on like analog communication, and we don't have IP or TCP protocol in the first generation, and the maximum data rate was about 1 or less than actually 1 kilobit per second. One of the systems is called Nordic Mobile Telecommunication, NMT, in the Nordic countries. Then starting from 1991, we started to have the second generation, which is GSM, known as GSM, where the data rate was around 10 kilobit per second. But it was also developed with the GPRS and the Edge system and enhanced Edge, where we reached it to in the uplink to up to 200 kilobit per second, 2006. Then by 2001, actually, it started the standard of the UMTS, where by 2009 it was able to achieve up to 22 megabit per second in the uplink. And then the fourth generation started by 2010, and it was able to achieve up to 500 megabit per second in the uplink and 3 gigabit per second per sector in the downlink until 2016. And in the 5G, we are now going to the 5G, where they claim at least that it can support up to 10 gigabit per second in the uplink and 20 gigabit per second in the uplink, in the downlink per sector. And also we will have the development of 5G millimeter waves, which should be able to achieve up to 50 gigabit per second in the uplink and 100 megabit per second in the downlink, which is actually, it is huge. It is really huge. So you can see here, this is the funny picture about the wire lines connections and how it is messy. It is really difficult to maintain and to follow. So wireless communication will be a solution for many like applications in the near future. Okay. But of course, in wireless communication, we have a lot of also problems like higher losses, fading because of the multipath, fading behavior in the fading behavior actually is uncertain due to the time varying nature of the channel. So the time varying nature, the channel is dynamic, so everything can be changed very fast. So it is really hard, even if we are able to identify the channel, but this will be valid for short time by using the organizers, for example, the channel equalizer. Sorry, yes, by using the channel equalizer, we can also like identify the channel, but still it will be valid for a short time. Then we will need all the time to identify the channel. We have additive background noise, we have interference from other users of the channel. So we have different kind of problems in wireless communication. And one of the major problem in communication, that the bandwidth of the available channel, it is up to 6 gigahertz. It is most of the channel is already licensed. So you can see in this figure that there are many users. They are licensed to use certain bands. For example, some band for the cellular network, some band can be used by TV, like analog TV, some bands for the digital TV, and some bands for the radio system, some bands for the military system. So the bands are already occupied. So most of the band is occupied. We have only very small, like free bands that can be used by utilized by for example the Bluetooth and those free that they don't need to have a specific license. But still there are some regulations that to use those bands in terms of usage power, for example, like 2.4 gigahertz and around 800 megahertz. So we have a few bands free, but 99.99 of the band actually it has been already licensed by many services. So it is not that available that you cannot just say that, okay, and now I want to install a new communication system over that band, because that band might be already licensed, so it is not free to use. Okay, so the spectrum is one of the like bottleneck of your communication and future communication systems. Because of that, to handle this problem, we should actually, and we have already use very highly efficient spectrum for the band. So the efficiency is measured by bit per second per hertz. So now we need to use many bits per second for each hertz for the available spectrum in order to maximize the efficiency of the spectrum. The second is using interference management. So we try all the time to minimize the interference by using some advanced technologies, advanced techniques in order to remove or to minimize the interference part, or in order to increase the efficiency. The third possible way is to use cognitive radios. Cognitive radios is one of the new technologies that because of the fact that even the spectrum is licensed already, but the primary user or the user who pay for that band is not necessarily that they use the band 24 hours a day and in every point on every geographical area. I give example. If some of the band was used for radar, for example, for radar system, but you are in area far away from any radar system, so even that band is licensed, but with using cognitive radios, they can listen to the band. So if the primary user is not exist or in that geographical area, then it is free to use. Okay, and even if the primary user is available in some geographical area and some time, but with using some like smart or intelligent way of transmission and reception with small power, then we can achieve some secondary communication in the primary band, with the condition that we must not making any harmful interference to the cognitive radio. So this is one, it is not actually new technology. It might be here for more than 10 years now, but it is one of the possible approaches to mitigate or to handle the the congestion in the spectrum. And the fourth possible way is to use frequencies or carrier frequencies more than 6 gigahertz. It is called millimeter waves, like up to 30 gigahertz or 40 gigahertz. However, remember that there are a lot of problems associated with the wave propagation at those bands, because at very high frequency, like extremely high frequency, 30 giga, 40 gigahertz, the electromagnetic waves will be absorbed easily by the walls, for example. So the propagation behavior of the electromagnetic wave is not that good. Because of that, it is not possible to use like millimeter wave to propagate the signal for large distance. And however, of course, there are some specific applications for the millimeter waves, like for short distance in closed areas, like in airports, for example, where there are a lot of people and we want to give the service for like hundreds of people at the same time with high data rates. Then millimeter waves can be good solution. Of course, there are still open questions about it. Even some commercial devices have already started at 24 gigahertz, and it will be part of the 5G, but still there are some open questions about, for example, about the biological effect of this millimeter waves, or how this millimeter waves will be affecting the human cells, for example, on the long run. So there are still open questions about these millimeter waves. We can see here how is the propagation of the waves. So we have multi-paths. So if we have, for example, the transmitter in this signal, so, and this is the receiver. So when the signal comes from the transmitter to the receiver directly, we call it line of sight. But the same wave, it might reach to the receiver also from different paths, through reflections or by diffraction or by scattering. So we will have actually multiple version of the original signal. Then we have multipath signal, and this we might have in the baseband like intersymbol interference. We might have also fading channel in the band pass because of the destructive fading of the signal. So actually we have a lot of problems and the challenges in wireless communication. However, of course, we can see that engineers were able to solve, and scientists were able to solve many of these problems, and actually some problems becomes also benefits. There is no time to explain these in details here. Okay, yeah. Now we come to the very important topic also in this lecture, is the quality of service. We said that communication is important for smart grid, okay, but not any communication. So every part in the smart grid needs some certain specification to guarantee the successful communication in that part, in the control, in the protection, in monitoring, for example. So we have all the time in the sensing, for each type of operation of each type of service, it needs certain communication quality. Okay, so in order to handle this, what are the quality of service of communication system? Okay, so here we can introduce part or few of these communication service. So we have, for example, communication reliability, how the communication is reliable. What we mean by reliability, one of the meanings is that if in case of abnormal or some conditions that they are not a normal condition, like storming, for example, earthquake, so we will still have a communication in the system or not. So this is called communication reliability. Of course, we can always increase the reliability by increasing the redundancy in the network. Then we have the security. Security is one thing that usually we don't see but directly, but we might get affected by it. So the communication should have some high resistance against unauthorized access of the network. So the security actually is one of the major vital requirement of a smart grid. Because if hackers were able to access the control system, for example, in smart grid or in power system, so the disaster could happen. For example, just think if or imagine that if they come to the big city and they switch off, they made some artificial blackout in that city. So what will be the cost of such hacking of the system? Or they can also break the privacy of people, by reading the smart grid or the smart meter readings of some people, and then they can track what they are doing in their home. For example, this guy is cooking at the mid of the night, for example. So you can see that the security and the privacy, they are very, very important in smart grid. So this is major thing in quality of service of communication. Outage probability. What is the probability that your system becomes in outage, so you don't get any access? So this probability should be very small, like 0.0001, for example, in some systems. And even in case of outage, we should have some kind of redundancy that we can use, or standby system that we can use in case of outage. communication itself, in the communication performance, we have the throughput. What is the throughput? The throughput is the information rate. The throughput is different than the data rate. Data rate is the data rate. For example, you can have data rate of 1 megabit per second, but in this 1 megabit per second, not all of them they are information. We have some coding, some bits for coding, some bits for addresses, some bits, for example, for security, and so on. But the information itself, the part of the information, is called the throughput. So for every communication system, we have to have some certain throughput for that communication system. Okay, if we want to send, for example, video signal, or we want to send control signal, the demand here is different. Video signal usually needs much more throughput than control signal, that just to send like switch on and off, for example. Okay, and delay is very important also, especially in control application, because if we have large delay, or the delay is larger than certain value, then we might have instability, or we lost the control of the system. In the protection, for example, in power system, it is very important to have fast reaction or fast response to cut a certain like line at certain time. So delay is very important here in communication systems. Actually, this is one of the drawbacks of 4G and 3G, that we were not able to achieve certain delay. For example, we were not able to achieve 1 millisecond delay only in the system. Because of that, it was not possible to use them in many protection and control applications. But in 5G, we hope that we will be able to achieve this 1 or 2 millisecond delay end-to-end delay. And delay spread is called jitter. So the delay spread is the difference between the maximum delay and minimum delay in the network. Because of the wireless communication, the delay is not necessarily to be fixed for every packet. So some packets might receive or might face large delay, some packets might face small delay. So the difference between the highest or the maximum delay and the smallest delay is called delay jitter. So of course, in communication system, for good communication system, we need this jitter to be as small as possible. Bit error rate is also important. So large bit error rate means that we have larger possibility or larger probability that the packet will not be decoded correctly. Of course, we use always channel coding, as we mentioned before. In the channel coding, we can increase the number of bits for correcting the errors if we have errors inside the packet. So the bit error rate is one important part of the quality of service in communication performance. Packet losses can be generated because of many reasons. One of them, of course, due to the large bit error rate, but also we have other reasons for example, memory overflow, or because of the congestion inside ad hoc networks. So we have different kinds of other reasons of the packet losses. Most of them, they are already given in the slides, so you can go and read them. Communication cost. The cost of communication is also important. Of course, it is not easy to buy whole or full satellite system for certain small application, because this will be very costly, for example, or for example, it is much easier to buy SIM card from a mobile cellular network in order to have a communication between devices than to send or to use a standalone network. But of course, we need all the time to compromise between costs, performance, quality of service, reliability, security. So we have many things that we need to compromise inside power systems. And also the priority of the network. Of course, you can have a contract with a third party like cellular network operator that your packets will have all the time the highest priority for the transmission, so to minimize the delay and so on. Here we have just like description about these performance, about throughput, about the delay, the jitter, bit error rate, packet losses, and so on. Security also, as I said, is very important in smart grid, but I'm not going to explain it here because we will have different lecture about the security issues in smart grids. But it is good to mention here that hacking of communication networks can be very costly and even a disaster, especially in big and vital services providers such as smart grids. So here it is very important that one must take this like very seriously about security issues. Because of that, in communication system we use different levels of security, like encryption, like ciphering, authentication processes, and so on at higher layers. And actually nowadays we have also security, like we introduce also security in physical layer, like in channel coding and in MIMO code book and so on. So security is one of the very important issues in smart grids. So smart grid cyber like threats have the potential to like breach national security, economic stability, health systems, safety, and even physical security. So cyber security is very, very important and essential in smart grids. Privacy also, as I mentioned, it is important to be protected. Of course, some users maybe they don't care, but for others they do care about their privacy. So it is not good that if someone was able to hack or had an access to your smart grid or to smart meter, sorry, and being able to see what you are doing inside your home. So for example, we have this fridge like periodic working of the fridges, and also for example at certain time you have your oven on or your boiler on and so on. So those privacy information should be protected in smart meters, and the privacy thing is one of the important parts in smart grid communication reliability. We also mentioned about this. Here in this part, I introduced some review of the communication protocols, but actually because of the time now, it might not be possible to go through them, but you can read them just for a general knowledge about, for example, Bluetooth, how it works, and what are the communication performance. For example, it can achieve a high data rate from 1 megabit per second up to 3 megabit per second. This is actually Bluetooth up to Bluetooth 3, but now we have also Bluetooth like version 5, which can achieve even much higher data rate than 3 megabit per second, but still it is not very high data rate, whatever. And it is used for wire free, for short range communication, and also here we have some like specifications of the Bluetooth. And then also we have the Zigbee. Zigbee is also low cost and low power consumption, short and or personal area network protocol. And for the Zigbee, it is different than Bluetooth, because it can be connected to many like devices within a network. So we can actually formulate a mesh network with up to 64,000 devices with the Zigbee. So Zigbee is actually like perfect solution for gathering information from smart meters in big like buildings, and it will be also one of the protocols in the IoT devices. So for example, if we have 1,000 sensors in certain areas, so we can collect the data through the Zigbee to the data concentrator before it is transmitted over the wide area network. Okay, so for example, few features of the Zigbee, like it is simple to install, reliable data transfer, extremely low cost, reasonable battery life, maintaining a simple and flexible protocol, and so on. So this is just one figure about how to make the Zigbee mesh network. Then we have the protocol of IEEE 802.11. Of course, we have now many standards like 11A, 11B, 11J, 11N, and so on, AN. So we have many new standards for those which can achieve very high data rate. Now they talk about even gigabits per second for the data rate. It can be also connected to MIMO, and also it can achieve very high reliable communication, which can be also part of the in the smart grid. Okay, cellular network. Also, this is the basic GSM architecture, where we have the base station controllers. We have the base transceivers, which known as base station, where they can communicate with the mobile network and from the base station to the mobile is called downlink. From the mobile to the base station is called uplink. And then we have interfaces between each terminal. For example, between the base station to the mobile is called air interface. Between the mobile stations to the base station controller, we call them a base interface. Between the base station controller to the core network or network substation, we call them as a interface. And then we have the mobile station controllers and a lot of actually items here that formulate the core network and how it is connected to each terminal, and how to record the like dynamic database for the users and so on. So, but I'm not going to explain this structure in details because of time. Of course, then introducing the GPRS. Then here we have the UMTS, or the third generation, and then we have the fourth generation. Of course, in each generation we try to minimize those connections between the core network and we actually minimize the distance between the core to the mobile station. So we move a lot of functions of this core network and the base station controllers to be within the base station, as done in the protocols of the fourth generation and also in the fifth generation. Cognitive radios, I already introduced them here, but I will just skip this. But you can see this is part of the structure of the cognitive radio. We have external and external sensing for the spectrum. We have here software defined radio, because we need a radio that it can move from spectrum to spectrum easily, to find and to track where is the free spectrum in order to use it. Then we have cognitive engine here in order to have an idea how is the spectrum, or how is the external environment and the interference structure outside the node. In this figure we can see how the communication can be connected, for example, in certain plant or in certain field. I think this might be like oil field. So we have like tanks, for example, we have chemical injector, we have here like oil level, gas pressure. You can see here we have actually a lot of sensors and automation here. So we might have like thousands of sensors distributed here in this field. So those sensors, it is not easy to connect every sensor with a wired line. It can be very costly, and actually some of sensors, they are in moving paths, so it is not even possible to connect a wire line to each sensor here. So wireless sensors is one possible solution here to be connected by wireless communication, and also taking control action from the control room. It is also possible to be done over wireless networks, actually even inside the plant itself. So you can see that here we have wireless, but it is possible to have also wireless communication. For example, if we inside the rotor of the motor. For example, we can bot or augment some sensors there for measuring the temperature, measuring, for example, the vibration inside the rotor, and these signals could be sent like over ultrasonic, for example, or because electromagnetic wave maybe it is not possible because of the shield over the rotor of the motor, but also with ultrasonic waves it can transmit a lot of information which can be collected, and so in the future we will have more and more sensors inside the plants itself. Okay, this is very similar to the previous picture that we have seen about smart grid communication manifestation. We have wireless, we have wireline. In wireline we might have fiber optic, power line carrier, Ethernet, DSL. In wireless we might have wide range or short range. In the wide range we might have standalone system like private networks, and we might have third party like cellular networks or satellite systems. In the short medium range also we can have standalone like Wi-Fi, Bluetooth, Zigbee, or we might have also third party like machine to machine, device to device under 5G networks. Internet of Things, we have already mentioned them, so we can have a lot of devices. Actually, a general rule that every device or every equipment might have any benefit by being connected to the internet. It should be connected. This is the general idea. So for example, for this your lamp at home, it might be connected to through the Wi-Fi, so you can switch on or off your lamp, for example, from anywhere when you go to your bed and you start reading something, and then you from your book, and no need anymore to stand up from your bed to switch off the light, because you can switch it off using your, for example, mobile phone, or even using your smartwatch. And from home you can, for example, check what you have missing in your like fridge that you can bring with you, or you can switch on the coffee maker like remotely, and so on. This is actually simple applications for personal use, but also for in factory or in industry. There are in smart city, in smart grid, we have a lot of applications that can be, and services can be done with the Internet of Things. So that's actually all about this small lecture. So it is only one lecture. We try to introduce the communication concept and also some services of the communication inside the smart grid. As I said, that in smart grid the communication is needed for monitoring, for synchronization, for control, for protection, simply for every operation inside the smart grid, we will need a communication. The communication can be wireless, can be wireline, but of course we rely with time more and more over wireless because of the cost, because of the flexibility and many other things, and also the recent reliability introduced with the 5G, and we are looking for even more and much more reliable communication solutions. Thank you very much for watching this lecture, and wish you that also interesting watching for the other lectures in this course. Thank you.